All right, let's take a look at solving radicals. Now, we talked about restrictions, we talked about our solving. So here we're going to solve. We haven't talked about solving yet, but we did talk about restrictions. And we're going to connect why we talk about restrictions and solving. So we're going to solve x, we're going to solve the root of x plus 1 is equal to x minus 1. What we do know is that x plus 1 has to be greater than or equal to 0, or x has to be x plus 1, x has to be greater than or equal to negative 1. That's part of it. But I also know that's part from here. But from here, I also know I can't get a negative number coming out of my root, right? So I have to go x minus 1 has to be bigger than or equal to 0. So x has to be greater than or equal to 1. So the more restrictive domain here, if I were to put a number line on both, there's 0, there's negative 1, there's 1. Well, here's greater than or equal to negative 1. Here is greater than or equal to 1. So this is the more restrictive domain. So we choose that one there, right? That's more restrictive. So and that's where my overlap happens. So my any x value I find at the end has to be greater than or equal to 1. Okay. So now we're going to do the solving part. So we have root x plus 1 equals x minus 1. So now you're asking, Mr. Van Dyke, how do I get out of this root? Right, so here's what we're going to do. We're just going to treat each side and square each side, right? So what we do know is that squaring undoes the square root. So that's just going to be x plus 1. But here I'm going to get x minus 1 times x minus 1, right? I've squared it, but now I need to do all the operations. So I'm going to x plus 1, and this will be x squared. So I'm going to do the FOILing operation here, right? If I have two binomial factors, I'm going to do the FOILing, get that taken care of, and then I'll get x squared minus 2x plus 1. And let's do a little algebra there. Minus x minus 1, minus x minus 1. And I'm going to get 0 is equal to x squared minus 3x, and that's it. What I need to do is pull it apart together. Let's take x and then x minus 3. And we just know, as a reminder, if I have a times b, any two expressions equal to 0, either a is equal to 0 or b is equal to 0. So I'm going to try both things here. So this is multiplication. So x is equal to 0 or x minus 3 is equal to 0. And what this means is that I have to find a direct solution for x. So I'm going to add 3, and I'm going to get x is equal to 3. And x is equal to 0, so I'm going to get the solutions x is equal to 0 and 3. But 0 is less than 1, so only x equals 3 is a solution, right? Because if we put 0 in, let's see what happens. If we put 0 in, let's see what happens, because I don't think anything nice is going to happen. What we're going to get is 0 plus 1 equals 0 minus 1, and we're going to get the root of 1 equals negative 1 again, and that's just not going to work, right? Then we'll just get 1 equals negative 1, and that's just not true. Let's try our other solution. So this was try x equals 0, just to show that it's not a solution we can use. Let's try x equals 3. And here, when we try x equals 3, we're going to get 3 plus 1, square root that. And we're going to get 3 minus 1. And this is going to be root 4. This is going to be 2. And then we'll get 2 equals 2. Hey, that works. So that's why 3 is a solution and 0 is not, right? So we have to make sure that we know what our restrictions are. So either we have to go through the restrictions and check what's allowable, or we have to check our answers and see what works out, what doesn't. Okay, number 5, let's do that. So we'll do 3 minus 3x to square root equals 3 plus 3x plus 2, and we'll square root that. And what we want to do here is the same thing again, but we're going to square and square again. So we're going to square this. We're going to square all of that. And it's going to take a little doing, but we'll see what happens here. This will be 3 minus 3x. So that side is nice and easy. But this is going to be 9 plus 6, 3x plus 2, plus 3x plus 2, right? If I FOIL everything out, right, if I were to do all this, so if I made a note, I did 3 plus root 3x plus 2 times 3 plus root 3x plus 2, what we notice is we're going to get a perfect square out of this, obviously, as well, too, right? So, but this will be, the first one is 9, and then it'll be 3 plus 3x plus 2, and then the last one will be plus, the inner one will be 3x plus 2 again, and then the last one will be plus 3x plus 2, right? 3x plus 2 root times 3x plus 2 root just takes away the root, and I get 3x plus 2. What we're going to do is just move everything to one side. Minus 9, minus 9, minus 3x, minus 2, minus 9, minus 3x, minus 2. So let's see here. 3 minus 9 is negative 6, minus 2 is negative 8. So on the new line, we're going to get negative 8. And negative 3x minus 3x is negative 6x. Yep. So far, so good. Bit of work to go, but that's fine. And then we'll get 6, and then we're going to get 3x plus 2. Now we can square both sides again, and it'll be a little doing. Actually, you know what? Before we square, let's make our life just a tiny bit easier for ourselves. Let's make it a tiny bit easier. And I'm going to factor out a negative 2, and this will be 4 minus 4 plus 3x equals 6, 3x plus 2. And then I'm going to call this 4 plus 3x equals negative 3. I'm just dividing this out. Divide by negative 2. Divide by negative 2 to get rid of each there. I'm going to get 3x plus 2. Now I'm going to square each side, and it's going to be nicer numbers, so we're okay. Notice how I didn't check the restrictions this time first. We're just going to do it by checking. So this will be 16, that's 12x, so this will be plus 24x plus 9x squared, right? That's good. And our next one here, this will be 9 times 3x plus 2, right? Because the squaring gets rid of the radical. We got to distribute one line here, so we're going to write this one more line, and let's write it in order, polynomial order. So 9x squared plus 24x plus 16 equals 27x plus 18. Let's get everything over to one side to solve it. I know we didn't do a whole lot of solving for polynomials, but we're just mostly going to treat it as factoring and finding the value after factoring. Okay, and so what we're ultimately going to get is 9x squared minus 3x, and then minus 2 equals 0, right? That's it, that's it. Let's use the box method here, 3x and 3x. Let's try that. This is minus, so this is minus 2. Let's go plus 1. Yeah, that works out. So I'm going to have, after the box method, I'm going to have 3x plus 1, and I'm going to have 3x minus 2 equal to 0. That means 3x plus 1 is equal to 0. And that means then x is equal to negative 1/3. Or 3x minus 2 is equal to 0. And x will be equal to 2/3. Right? But now we need to check our answers. We need to check if anything works. Well, let's check. Oh man, this is going to be messy to check. So actually, let's just go with our restrictions here. Let's check 3 minus 3x has to be greater than or equal to 0. If I do this, minus 3, and I'm going to get minus 3x has to be greater than or equal to negative 3. I divide that, x has to be less than or equal to 1. Okay, so that's one restriction. Let's check our other restriction. X has to be greater than, 3x plus 2 has to be greater than 0. So what that means here is that x has to be greater than or equal to negative 2/3, right? All right. Well, looking at the restrictions, this should fit. Let's see if it works or not, though. So, restriction-wise, everything looks okay. But I have a feeling something's still not going to work out. So we're going to try x equals negative 1/3. And let's see if that helps. Negative 1/3 is greater than negative 2/3, and it's less than 1, less than or equal to 1. But still, we might run into something. So we'll get 3 minus 3, negative 1/3 here. That altogether is going to be 3. That's going to be positive 1. So this is going to be 3 plus 1. And this will be root 4. That'll be 2. And now for the other term for it, this will be 3 plus 3, negative 1/3 plus 2. And what I'll get here is going to be 3 plus, and this will be negative 1 plus 2. So this is just going to be root 1. And this is going to be 3 plus 1, and that's 4. And my equation now is going to be 2 equals 4. So that's false and not a solution. So we can still get non-solutions even though the restriction says that it's okay, right? And that often can be because, like, when we did the squaring, we lost a negative somewhere, right? So it can happen when we lose the negative somewhere if we've done the squaring. You can try it for yourself if you think that factoring the negative 2 came out and did something funny. Oftentimes we can lose solutions when we're squaring as well, or find negative solutions that's not defined. So let's try the other solution we want to try here was positive 2/3. So let's try the other solution of positive 2/3. I'm going to do it much the same way. Try the left side. So this was left and this was right. So let's try the left side. This is going to be 3 minus 3, 2/3. Right, and so root, and that's going to be that's going to cancel out the 3's. That'd be 3 minus 2, and that'll be just root 1. So that's the left. Let's try the right. So this will be 3 plus 3x plus 2. And once we do that, this is going to be 3 plus 3, 2/3, plus 2, get rid of that, and we'll do 3 plus that. 2 plus 2 is 4, so we get root 4. This is going to be 3 plus 2, and that's 5. And so we're going to end up getting 1 is not equal to 5, false. So, so x is empty, right? No solution possible. No solution. So the two values that we found don't work. So only no solution here. So a lot of work, but we got there and we sorted it out. Let's do the last one and make sure that we get this. I'm not going to bother with the restriction set for this one. We're just going to try the answers just to be sure. And we can see if it works or not. Minus x minus 1 equals 2. Because usually if you find that you try the solutions and they work, they fit the restriction set anyway, right? So trying the solutions is the best option. The restriction set may tell you, but it may not always tell you. Okay, so we're just going to go ahead and we're going to take one square to one side because we can't just keep squaring. So I'm just going to square one side over and over and over again. We want to try and spread out the radicals on different sides. Why we do that is because if we keep repeating the multiplication, the FOILing, the binomial multiplication, it's not going to work out well, and we'll need to spread more and more out. So this just ensures that we have less total steps to do. Even though there's still a lot of steps, this just ensures less total steps. Okay, And then we can go ahead and square everything. We're just getting rid of the square there. And we're going to get 2x plus 5, right? 2x plus 5. And then here, this is going to be 4 plus 4 root x minus 1. And then we'll get plus x minus 1 here. Let's bring everything over to one side. So 4 minus 1 is 3. So I'm going to do minus 3 minus x. Minus 3 minus x, right? 4 minus 1 is 3. Writing this again, I'm going to get x plus 2 equals 4 root x minus 1. There's no GCF to take care of, so I'm just going to square everything again, square everything again. Gets to be a little bit nicer. This is going to be x squared plus 4x plus 4. This will be 16x minus 1. And this will be x squared plus 4x plus 4 equals 16x minus 16. Right, we're just moving through here, applying our operations as we need to. This will be 4x right there. Now we're just going to put everything on one side and do our solving. Plus 16 minus 16x plus 16. And we'll get a final quadratic here of x squared. 14 minus 16 is minus 12x. And then 64 plus 16 is plus 20. And I see some factors that I think I can use. It looks like 2 and 10 would be the best factors here, right? So this could be x minus 10, x minus 2, negative 10, negative 2 multiplied negative 20, and negative 10, negative 2 add to negative 12, so that works. So I'm going to get x solutions of x equals 2 and x equals 10. So we're going to try them now. So we're going to try x equals 2. Let's try the little one first. So we'll get 2 times 2 plus 5 and minus 2 minus 1 equals 2. Well, that would be 2 times 2 is 4. 4 plus 5 is 9. Root 5 minus root 1 is equal to 2. Well, this is 3 minus 1 equals 2. I get 2 equals 2. Hey, so x equals 2 works. Let's try x equals 10. And then we know if both are in our solution set here. So try x equals 10. And we're going to get 2 times 10 plus 5. Okay, minus 10 minus 1 equals 2. Okay, so this is going to be root 25. 2 times 10 is 20, plus 5 is 25. And then 10 minus 1 is root 9, and this will be 2. Then I'm going to get 5 minus 3 equals 2. And then I'll finally get 2 equals 2. Right, so we test our solutions, right? Remember kind of when you did linear systems last year, this is kind of us like testing our solutions like linear systems can. And we did it. We did it. We solved radical equations, right? So looking at your homework, there's a couple funky ones. But if you run into anything that has fractions, what I would say, since you have an equation, you can multiply denominators across and probably make your life a little bit easier for some things, okay? So there's some simplifications that come nice and easy in some places if you multiply denominators across. I'm specifically looking at 3m and 3n in our workbook. Sometimes you're going to see some that are just not possible. I see at least 2 in question 3 that are not possible to accomplish. And there might be more in some other ones over here as well too. So looks good. I think we have enough to try it out. When you're doing the word problems, when that's part of your homework, just be mindful about how you're setting things up. It shouldn't be too crazy. Most of the equations get given to you, so you should only do some light modifications or some light rearranging. It shouldn't be too intensive to rearrange everything. All right, good luck. Hopes this helps. Have a good day, pre-AP 11.